Hello everyone, I hope you are doing well. So in today's video, I'll be going through the 2019 Specialist Maths Exam 2 for the Northern Hemisphere. Like always guys, before I start this video, if you guys want private tutoring in Specialist Methods, Physics or Chemistry, you can always email me through this email. Yeah guys, let's smash through this video. Question 1. The graph of which of the following relations does not have a vertical asymptote? Okay. Normally, to find the vertical asymptote, we always let the denominator equal 0 and we solve. If there is a solution, if there is a real solution, hence there will be a vertical asymptote. So we need to check all of them. So for example, this one, let the denominator equal 0, x equals 0 is a solution. So we have at x equals 0, we have a vertical asymptote. So this one does have a vertical asymptote, so that's wrong. What about the next one? So x squared plus 1, solve that. So x squared plus 1 equals 0. X squared equals negative 1. This actually does not have a real solution. Yeah, so hence probably B is the best answer for that one. B is your answer. Let's check the other ones also. X squared, so next one, x squared. So if we let x squared equals 0, x equals 0. Also an asymptote at x equals 0, so a vertical asymptote. Also the same for this. X plus 4, we have 2. So we have x0 and x negative 4. We have 2 vertical asymptotes. The last one, square root x plus 2 equals 0, which is just x plus 2 equals 0, x negative 2. X equals negative 2, we also have a vertical asymptote. So yeah, your only B is your answer. So every time you're trying to look for the vertical asymptote, always let the denominator equal 0, and if there is a solution, that is your vertical asymptote. Done. Question 2. Let's look at this. A curve given by x equals 3 secant t this and y equals this can be expressed in Cartesian form as well. You should know how to do these questions. They are kind of repeating every year. And so we have secant and we have tan. What relation can we use? If you look at your formula sheet, we know this relation. 1 plus tan squared t is equal to secant squared t. So in this case, we want to find tan squared and secant squared. So let's do that. Let's solve that for. So it'll be x minus 1 over 3. That's your secant. And imagine squaring it. So it'll be x minus 1 squared all over 9. That's your secant squared t. Done. So we write that as 1 plus equals x minus 1 squared. We also want to find tan squared, so also easy because we have this over here. Let's solve for tan. It's y plus 1 over 2. Imagine squaring both sides. That's your tan squared t. So let's write that down. Done. So that's your relation. That's in Cartesian form. So bring it, you can write it as x minus 1 squared over 9 minus y plus squared over 4 equals 1. So this is a hyperbola. Which of the following is the solution? Looks like E is your answer for that one. Nice. Question 3. The maximal domain and the range of the function f of x, where a and b and c are real constants, with a is greater than 0, b is less than 0, so b is a negative number, and c is greater than 0, are respectively what? Okay, not too bad. So, we know to find the domain of cosine inverse is we let the inside be between -1 to 1. But, be careful. Remember, b is less than 0. So, what we're going to do, imagine, so b is a negative number. Remember what happens if we divide something by a negative number? It switches signs. So if I was switching, so it'll be -1 over b greater or equal to x greater or equal 1 over b. Now this is not a good sign. We need to kind of switch them to make it nice. We have to switch these from opposite sides. So it'll be 1 over b x -1 over b. Hence this here is your domain. So from 1 over b to -1 over b. Done. Which one does that look like? Okay, so These are wrong. Okay, what about your range? Okay, have a look at this. We know that the range of a cosine inverse, so your y, it's like a normal cosine. So imagine like, y equals cosine inverse, so x. We know it's normally as, it'll be written as, so your range must be between 0 to pi. It's also in your formula sheet. And let's see what's happening. So there's a dilation by a factor of a parallel to the y-axis. So every y value is getting multiplied by a. So if I was multiplying everything, so a times 0 is just 0. Ay pi a. Okay. And there's also a translation up, or, because remember c is greater than 0. So there's a translation up by c units. So the y values, increased by c units. So this will be c. Ay plus c. Pi a pretty much plus c. Hence, this is your range. Done. Easy. So, which one's that? Looks like D is the answer for that one. Nice and easy. Look, you can do this quite quickly using your CAS, and let's do it by CAS 2 to show you how to do this. Normally, I'm just trying to show you guys how to kind of, let's say it's an exam one. I want to make sure you guys understand. If you get some questions like this, a lot of students might, not know the basics of like how to do the domain. So I want to make sure to do it by hand first, and let's do it by CAS. Let's do that. So what we want is to first find the domain, which is going to write domain of a times cosine inverse of b times x plus c comma x. Given we need to write those conditions, be careful. We know that a must be greater than 0 and b must be less than 0. And lastly, c also must be greater than 0. Press enter. Done. Here are your conditions, and this is your domain, which we've, that's what we've got. Perfect. Now, okay, we've got this domain. Now you're probably like, how do you find the range? Well, let's think. Okay, if I was just, let's say sketching this, now we have the domain. If I was sketching this, have a look. I'm going to do a small sketch here. Let's say we're sketching this. How does this look like? What does the graph look like? So remember, be careful. So b is less than 0. So let's say it's a cos negative x. So you know what's happened? So this is normally the graph of cosine inverse, but remember it's reflected along the y-axis, so it will look like this. Something like this, perfect. Where we already know this part here is 1 over b, just by the domains. Hence, what's your range? Well, the range is, what is, if you sub in, f of x, so f of 1 over b, you'll get this part over here, so this part, and all to the way this part, if you sub in negative 1 over b. See, just drawing this, you can actually just sub it in. So, for example, coming back, what I know is, okay, so the lowest point, we start from, we sub in 1 over b. So if you sub in x equals 1 over b, we get c. And the highest point we said was from negative 1 over b, which is a pi plus c, which we've already said that's your range from c to a pi plus c. Nice and easy. Question 4. Which of the following statement is false for Z1 and Z2 as elements of complex plane? Nice and easy. When you get questions like this, what you do, first thing, is go on your calculator. And let's actually make up some values. So let's say Z1 in this case is 1 plus i. Because remember, it's not giving us any conditions, just saying which of the following statements is false for Z1 and Z2, which are elements of complex numbers. So we can write as anything, like Z2, let's call Z2 as maybe 1 minus i. And let's see if the conditions are met. So what I'm going to do is, the first one, egg says, Z, let's call it Z1, because it just says Z. So Z to the power of 1 to the negative 1 should equal the conjugate of Z, absolute value Z squared. Make sure you put Z1 here for them. Enter. True. So this statement is true. It's not false. So that's also a right answer. Let's check B. The B set, it's saying that absolute value of Z1 plus Z2 is greater than the absolute value of Z1 plus the absolute value of Z2, which is a false statement, so probably that's your answer. Let's check the other ones first. Let's make sure to check the other ones. So the next one is just Z1 over Z2 equals Z1 times the conjugate of Z2 absolute value of Z2 all squared. Enter. It's also a true statement, so that's right. Let's check the D. Absolute value Z1 times Z2 is equal to the absolute value of Z1 times the absolute value of Z2. Enter. Also a true statement. Lastly, let's just check the other one. Absolute value Z1 Z2 is equal to absolute value of Z1 and the absolute value of Z2, also a true statement. And that's it. So the only false statement is B. So choose B as your answer. Look, when you get questions like this, use your calculator to your advantage. A lot of students might, just let Z be X plus Y, and they'll do algebra and it'll take too long. No, use your calculator to your advantage. Make sure, sub in some values and follow all those conditions and which ones are false and choose that as your answer. Done. Question 5. A circle defined by this, where A is an element of all roots, has a center and radius respectively given by what? Nice and easy. Let's do that by our CAS. So, okay. Let's write the equation. So it's the absolute value of Z plus A is equal to 3 times the absolute value of Z plus I. Given Z is equal to X plus YI. Done. Enter and we get this. We're going to square both sides. So let's square both sides. And we get this. And what we're going to do is finally we're going to complete the square because we want to make sure it looks like an equation of a circle. Answer, comma X, comma Y. And we get this. Okay, this is not a nice equation. Remember, an equation of a circle, we don't want these coefficients in front. And they're also negative. So what about if I take this whole thing and, wait. So what about if I multiply it by -1/8 to get rid of those -8 times answer. And okay, and let's go back to completing the square again. Answer, comma X, comma Y. Aha, beautiful expression. So what is your your center? It's A over 8, so A over 8 and -9/8. That's where your center will be. And what about your radius? You should know that this is your C squared, and the radius is the square root of this whole thing. So if I was square rooting this part over here, we get this. So let's write this all down. So we now know that A over 8 and -9/8 is your center, and your radius is 3 square root A squared plus 1 all divided by 8. So let's check. Looks like A is actually right for that one. Is it right? Let's check. The other ones don't look... Yeah, A looks very good. Done. Question 5. P of Z is a polynomial of a degree n, where, so n is just, okay, with real coefficient. Aha, real coefficients. So what do we know? The complex conjugate root theorem applies. Complex conjugate root theorem is going to apply here. Every time you hear the word real coefficients, always think complex conjugate root theorem. So P of Z is a polynomial of degree n with real coefficients where Z is an element of complex plane. 3 of the roots of the equations are these. So Z, so we have Z, 3 minus 2i. Z equals 4, which we can write as 4 plus 0i. Actually, just Z. Z that. And Z is equal to -5i. The smallest possible value of n, so the degree, is what? Well, you should know. We are applying the complex conjugate root theorem. It's not 3. Be careful. These are not just 3. It's the value of n is not going to be 3 because we have 3 solutions. Be careful. But we know that also there's going to be a solution 3 plus 2i. It's the conjugate of this, because remember the conjugate root theorem. Remember, this is going to be the same. Remember, so if this was z equals 4 plus 0i in this case, the conjugate is just 4 minus 0i, which is still 4 in the case. So that doesn't have a conjugate, so leave that. And also this one has a conjugate, which is 5i. So how many solutions do we have? We have 5 in total. So if you write them as, like a factor, so like this one, it will be z minus 3 plus 2i, z minus 3 minus 2i, z minus 4, like, it's very long, but like, z plus 5i, z minus 5i. And if you fully expand this, so z 1, 2, 3, 4, 5, we will have z to the power of 5 overall. That will be your smallest possible value of n. So 5. It will be a degree of 5. Done. Question 7. The gradient, let me just use the graph. So the gradient of a line that is perpendicular to the graph of the relation at any point x and y is half the gradient of the line joining P and Q. This is a very similar question in exams. I've seen this, I think in like the 2017, if I'm not mistaken. I think so, yeah. This question is just very, very similar. So what we know is the gradient of the line. So that is perpendicular, remember? So if M is your gradient, which is just, we write it as dy dx. We know that it's perpendicular. It's going to be -1. You remember that formula, -1 over m, where m is our gradient. So it's -1 over our dy dx. So that is, okay, we've got that. So the gradient of the line that is perpendicular to the graph of the relation at any point x and y, which is, yeah, dy dx at any point, is half the gradient, so half the gradient of the line joining P and Q. Easy. So remember using y2 minus y1. So in this case, let's call, yeah. So it's going to be 1 minus y divided by -1 minus x. Done. So we've got this beautiful equation, and we just want to get it in dy dx. So kind of rearranging it pretty much. All right. What do we do? Well, what we can do is like get rid of this negative. So for example, I'll make it a positive, but I'll bring it over this side, make this negative, make this a positive. And then flip it around. So if I flip it, I'll get dx d. So 1 over dy dx is just dx dy, which is half y minus 1 -1 minus x. And then remember, we want dy dx, so just flip it around. So dy dx is going to be 2. I'm going to take that negative out, so negative x plus 1 divided by y minus 1. Does that look like any of these? Okay, so we'll take a negative out of this one, so we can write 1 minus y. We've taken the negative out, and we can cancel both negatives here, so we can make them positive. Hence, which one looks like this one? 2. Looks like easy answer for that one. Great. 2x plus 1 minus y. Great. Yeah, that looks good. Question 8. The total area enclosed between the x-axis and the graph of this is closest to what? Look, when you get a question like this, which is the area and it's closest, what you can do is you can use your CAS to your advantage. Like, let me show you. This is a quick way, especially that you get decimal places like this. So go on your graphing and graph this. So absolute value z to x to the power 3 minus x squared minus absolute value of x. And we get this over here. Now we want the area enclosed. So the area like of this and this over here. So how do we do that? We just go on menu, analyze graph, and go to integral. We're going to start from here, and we're all going to go this. Of course, the area is going to be negative because it's below the axis, but remember, area is always positive, so it's going to be 2.02. Let's write that down. 2.02. So which one is your answer? Looks like D is the only closest one. So 2.015. Yeah, so D is your answer for that one. Done. Question 9. With a suitable substitution, this can be expressed as what? Okay, if we let u be 5x minus 1, dx is going to be 1 over the derivative, so which is 5 du. And to rewrite this, so the terminal here, if I sub in 1 in here, is 5, so it'll be 4 actually, and then 2, so 10, 9. The next one's 9. So rewriting this, it's the square root of, we know 5x minus 1 is just u, multiplied, by dx, which is just bring that 1 over 5 here, and du. So which one looks like this? 1 over 5, 4 to 9. Looks like D is your answer for that one. Done. Nice and very, very simple for this one, yeah. Euler's method with a step size of 0.1 is used to approximate the solution of differential equation, this, with y equals 2 and when x is equal to 0. When x is equal to 0.2, the value obtained for y correct to 2 decimal places. What? Let's do this by hand, and then I'll show you a quicker way to do it by CAS. So, okay, what do we know? Well, we know dy dx. I'm going to multiply both sides by y, so I can get rid of this here. It'll just be y cos x. We know our step size is 0.1. We also know that our x naught is 0 and our y naught is 2. Okay. So if we were trying to find, okay, x1 is what? It's 0 plus h. No, it's the, yeah, so it's just x0 plus h, which is, 0 plus 0.1, which is just 0.1. Great. So what's y1? y1, this is all in your formula sheet, so y1 is going to be y0 plus h times by this whole dy dx, putting all your initial conditions, these conditions over here. So it'll be 2 cos 0. So cosine 0 is just 1 anyway. So let's write that as 1. Oh, no need to write that, yeah. Oops. And that's it. And subbing those all in, so y0 is what? It's 2 plus 0.1, 2. Let's go on our calculator and write that down. So 2 plus 0.1, 2. And that's 2.2. So your y1 is 2.2. Done. Repeating this again, so x2 is what? It's now x1 plus h, which is 0.1 plus 0.1, which is 0.2, which is great. Remember, when x is 0.2, what is the y value? So we want to find what's y2. Same thing. y2 is going to be equal to y1 plus h dy dx, given, now you have to sub in these, sub in these values over here. So y is going to be 2.2 cos 0.1. And pretty much, yes, sub all the stuff in here. So h in this case is going to be what? Plus 0.1. And what's your y1? It is 2.2. Subbing this in, that's going to give us a y2. So this over here plus 0.1. 2.2 times cosine 0.1. Control enter, we get 2.4189. And which one does that look like? 2.4189. Looks like D is your answer for that one. That looks, is that right? Yes. 2.4 to 4 decimal places, 2.4189. Great, yes, that looks good. So, okay, that's the, the kind of doing it by hand, and it's very long. I'm going to be honest, it's a very long, repetitive process. But what about if I told you can do this very quickly using your CAS? Let's do that. If you write the statement in your calculator, Euler. So it's like a statement and bracket. What is your dy dx? First, you're going to write your dy dx. In this case, it's y cos x, done, comma, what is your independent variable? So what are we changing? Well, we changed that x values, yeah? Remember, we start off x0, and then we get x1, x2. These are the things that we're changing. That's called the independent variable. So our x value is our independent variable. And then what is the y dependent variable? So the dependent variable is the thing that gets outputted, or yeah, so for example, if you sub in x, what comes out of it? What's the output? It's the y value. So it's our y value, and it's the one that we're trying to find out. Comma, you're going to put these scribbly brackets over here. And now, where are we going to start? What x value are we going to start? We're going to start from 0. And we want to reach 0.2. And now here, we're going to have to put the initial condition. So, for example, x0 was 0. But what is y0? What is that y0? It's 2 in this case. We're going to put 2. And then the step size. So what is our step size? It is 0.1. Writing this on the calculator, it will give you the answer in a second. So let's do that. Let's write that. So Euler, y times cosine x, comma x, comma y, comma, these brackets over here, from 0 to 0.2, comma 2, comma 0.1. Enter, and we get this. So when x is, x0 is 0, it's, of course, it's 2. When x1 is, 0.1, it's 2.2. But here, when x is 2, so 0.2, this is our y value, which is 2.418, which is the same as we got. So yeah, that's a quicker way to do it. What about question 11? The vector resolute of A that is perpendicular to B is what? Now, this is what they're telling you. So if I was drawing a vector resolution diagram here, this is what we're trying to get here. We know this is B and this is A in this case. And this part, let's actually write it nicely. So for example, let's call this O. This is A. This is B. This is C here. Okay, and we call this vector B, like the B vector that is this whole thing, the long. We call this vector, vector B. This is vector A. And okay, so what the vector resolute of A that is perpendicular to B is this vector over here. This vector over here. This is the vector that we want to, get. That is perpendicular to B. So how do we get it? Well, to get it, we're going to have to get this vector over here plus this vector A. So we're going to go CO plus A, and that's going to give us the perpendicular vector. Now, you should know that CO, this vector over here, you start realizing, wait. Isn't O to C, the vector resolute, the vector resolute of A parallel to B, which is, OC. And yeah, if we can, and we know the equation for that, it's what? It's A dot B, B squared dot B. This is a formula you should know. So yeah, the vector resolute of A parallel to B is this. That's OC. So imagine like minusing it. So for example, because it's C to O, so it'll be minus. So it'll be minus A dot B, B squared dot B. Yep. Remember that A, I'm just going to put that plus A here. So I'm going to take this over here. I'm just going to say minus A. So overall, this is your equation. This is going to give us our perpendicular, gradient. And yeah, so you should have this formula in your sheet, and you should memorize it. It normally comes in exams, the vector resolute of A perpendicular to B. So it's very also important to know. Let's do it by calculator very quickly. So let's do it. If I define the vector A, what is it? So it is 2, -1, 3. Vector B as 1, 1, -1. And so let's write everything down. So it's going to be vector A minus overall the dot product of A and B norm. Remember, when norm is the magnitude of B squared times B. Enter, and this is your answer. So let's look at which ones are that. C is your answer for that one. They've just took a common factor of 1/3, so same thing. Done. Question 12. Given that theta is the acute angle between the vectors A and B, the sine to theta is what? you should straight away know that, okay, we want to find sine to theta. And we know that sine to theta is, if you look at your formula sheet, it's just sine theta cos theta. Okay. And we also know that when we have two vectors and the acute angle between them is what? Well, yeah, the angle between them is what? It's going to be, in this case, it's going to be, given that the acute angle between this and that, it's going to be A dot B, the dot product, times the magnitude of A times the magnitude of B times cosine theta. Great. So if we can find that cosine theta, we can actually sub it into this. And then we can also find this very easily. So let's do that. What's pretty much A dot B? Now, let's do this all by CAS, I'll be honest. So let's rearrange this to get cos theta. Cos theta is then hence what? It's just A dot B over the magnitude of A times the magnitude of B. So let's do this by CAS. So I'm just going to redefine these over here. So in this case, this here now is negative 2. This here is 2 and negative 1. The vector B is negative 4, 4, 7. So let's do this. So it's dividing. Okay, we need to go to the dot product. A and B. Norm, so the magnitude of A times the magnitude of B, and it's 1 over 3. So let's write that down. Cosine theta is 1 over 3. That's great. We have cosine theta. How do we get sine theta? Well, if we draw a right angle triangle, we know this is theta. So remember, our cosine is adjacent over hypotenuse. So it will be, this is 1 and this is 3. So we need to find this over here. So by using Pythagoras theorem, it's going to be 9 minus 1 square root, which is root 8. So we got that. Hence, that, so then sine theta is what? Sine theta is opposite over adjacent, so it's root 8 over 3. So we got cosine and sine theta, and that's it. Let's just go on our, hence sine 2 theta is just 2 sine theta, and sine theta is what? Root 8 over 3. Times cos theta, which is just 1 over 3. Using your CAS, let's do this. So combine this, so 2 times root 8 over 3 times 1 over 3. And that's 4 root 2 over 9. So which one's that? Looks like B is your answer. Done. Question 13 says, for vectors A and B and C to be linearly dependent, the value of this lambda is what? We know, always, when you hear the word linearly dependent, you can easily get that by not, so, okay, for linearly dependent, so linearly dependent, what do we know? Well, we know that the determinant, this is a kind of a statement, so it's very useful when, especially in exam 2, because you can do it by CAS. You can solve this very quickly by CAS. We know if, to find the, like what value of lambda will give us linearly dependent, it has to be the determinant for this whole, vectors A, B, and C must be equal to 0. The determinant must be equal to 0. So for example, what is your determinant? So this is what you would write in your calculator. You would write determinant, and you do a matrices. So a 3 by 3 matrices. So like this, and okay. So for the example, for A, let's put A first. So it's going to be, well, we're going, like, remember, I, so it'll be I, J, and K. So it'll be, in this case, for A, it'll be 1, 3, negative 1. Next one, B, is going to be negative 1, negative 4, 2. The other one is going to be negative 1, negative 6, lambda. Close bracket. And remember, for linearly dependent, the determinant must be equal to 0. And then we solve. Let's use our calculator to do this. So in other words, we write determinant. You go in here and you just go to a 3 by 3 matrix. And okay, so it's 1, 3, negative 1, negative 1, negative 4, 2, negative 1, negative 6, lambda, let's call it f because I don't know how to get lambda, but equals 0. And then we solve answer, comma, f. So lambda must equal to 4 for linearly dependent. So E is your answer for that one. Nice and very easy question. Done. Very, very common. Question 14. The position vector r of t of mass 3 kilograms after t seconds, where t is greater or equal to 0, is given by this. Okay, so it's a position vector. Okay. The force in newtons acting on the mass when t equals 2 seconds is what? Okay, so we want the force. We know that force is equal to what? Mass times acceleration. We know our mass, by the way. We know our mass, and that's 3. But what is our acceleration? Our acceleration, you should know. Our acceleration, this is position. Finding the derivative of position, so r of t, is going to give us our velocity. And finding the double derivative of the position gives us our acceleration. I'm going to write it quick. But in this case, what happens? So what is the acceleration at t equals 2? So it will be r of 2. So let's write down. So acceleration is going to be what? So let's put that down. So times r dot dot of 2. And that is going to give us our force. So let's first, define r of t. So r of t is what? R of t is given by 10t. Oopsies. R of t, 16t squared minus 4 over 3t squared, t to the power 3, sorry, t to the power 3, done. And now we find the double derivative to get the acceleration, so go in here and double derive this in terms of t, r of t, and we get this over here. Remember, t must equal to 2. And here is our acceleration. So multiplying this by mass will give us the force times 3. And that gives me 48J. Remember, this is your I component and this is J component. This question, be careful. It says the force. Remember, force is a vector quantity. You need to make sure it's in written data. They're not telling you find the magnitude. They're just telling you find the force. So you need to make sure 48J is your answer for that one. So C is your answer for that one. Nice. Next question. A lift accelerates from rest at a constant rate until it reaches a speed of 3 meters per second. It continues at the speed for 10 seconds and then deaccelerates at a constant rate before coming to a stop, coming to rest. The total travel time for the lift is 30 seconds. The total distance in meters traveled by the lift is what? Oh my God. If you do physics, or maybe if you did specialist units 1 and 2, these questions are very common. They are very easily done drawing a diagram, a velocity time diagram. For example, if you do, the specialist book has these kind of questions very, very commonly. So yeah, you should kind of see that if I draw a velocity time graph, look at the question. A car accelerates from rest. Remember, rest is where velocity is 0. So if I was just putting it here, 0, we start from 0. And it's accelerating. Remember, acceleration is the gradient of a velocity time graph. So if we accelerate constantly, acceleration is positive. Remember, if it's deceleration, it's negative. But here, it's accelerating. So it's going to be a positive gradient. So let's say, and it's constant, so it's going to look like something like this, some value. So a car accelerates from rest at a constant rate until it reaches a speed of 3 meters per second. So remember, this is velocity, so this here is 3. Done. It continues at this speed for 10 seconds. So a constant velocity stays at 3 meters per second for 10 seconds. We'll draw that. So from here to here, in this example, that is 10 seconds. And then deaccelerates at a constant rate before coming to a rest. So then deaccelerates too. Done. Okay. The total travel time for the lift is 30 seconds. So the overall from here to here is 30 seconds. The total distance in meters is traveled by. Now we know the distance in a velocity time graph is the area under the graph. So this area is your overall distance, the total distance. And that's, it's the area of a trapezium. Remember, the area of a trapezium is half, where let's say this is A, and So A is this over here, this part of it, and your B is going to be this part over here, and your height is going to be this height here. So it's going to be A plus B times your height, which is half. Your A is just 10, because we know that's 10 seconds, plus B, which is 30, which is the length of this, times your height, which is 3. 20 times 3, 60. So overall, that's going to be 60 meters. That's going to be traveled. C, done. Question 16. The object of mass 2 kilogram is traveling horizontally in a straight line at a constant velocity of magnitude 2. So imagine an object, say it's moving, to the right. So horizontally, so velocity is 2. The object is hit in such a way that it deflects 30 degrees from the original path. So it deflects, so it goes like this. So imagine this was originally was going like this, and so it deflects 30 degrees from its original, continuing at the same speed in a straight line. So still 2. The magnitude correct to 2 decimal place of the change in momentum in kilograms per meters per second of the original object is what? Okay, we know that the change of momentum is mass times final velocity minus initial velocity. All right, so what do we know? We know that the initial velocity, make sure these are first, treat them as vectors. So like, for example, so let's call the horizontal direction as I component and the J component as, up or down, So that's what we're going to do here. So for example, initially, so your vector, initially, the original, it's going at 2, and it's to the right, and we're taking right as positive, and it's an I component, so it's just going to be 2I. What about V, the final velocity? Well, this is your final velocity. Well, if we need to break it down to make sure it's in its, horizontal and vertical components, so breaking this down, it will be, so your I component will be 2 cos 30 degrees, I plus 2 sine 30 degrees, and that's your J component. So we got U and V in there. Now let's do it in our CAS. So let's define U, your initial velocity, as 2, 0, and your V as 2 cosine 30 degrees, comma, 2 sine 30 degrees. Done. So we got V and U now. Have we made any mistakes? Great. So remember, change in momentum is mass. So mass, which is 2, times the change in velocity. So V minus U, so V minus U. Enter, and we get this. And remember, we want to find the magnitude. The question tells us the magnitude, so norm. So the magnitude of the answer is, Control Enter, what? So that's your answer. It's 2.07, so that's your answer, which is E. Nice. Question 17. A ball is thrown vertically upwards with an initial velocity of 7√6, and it's subjected to gravity and air resistance. The acceleration of the ball is given by this. Okay, where V is the velocity when it's at a height of X meters above the ground level, the maximum height in meters reached by the wall is what? So that's the right what we have. So we have that initial velocity, so U is equal to 7√6 when T equals 0. That's your initial velocity. And we have our acceleration. So this is acceleration is given by negative 9.8 plus 0.1 V squared. So we have in terms of velocity, and we want to make sure it's in terms of height because we want the maximum height. So if you look at your formula sheet, what comes to mind? This should come into your mind. V dv dx is the most simplest one. That could help us here. So it'll be, that's your acceleration. So if I divide both sides by V, we get dv dx. And then 9.8 plus 0.1 V squared, all divided by V. And then we reciprocate it, so dx dv is going to be negative V divided by 9.8 plus 0.1 v squared. Okay, so, and now if we find the integral, we'll calculate x. But okay, so we calculate the integral. Now you should know that we can easily do every step. So you can sub in. Like if you're integrating, you'll get x equals blah integral of this plus c, and you sub in to find c. It's very long, but we can do everything in a second. And how? Well, let's think. What is the initial condition? Like in terms of this is velocity, what is the velocity, initial velocity we put on down? And what final velocity? What is our final velocity that we want to make? And write the equation like, your dx dv in this case, which is this, dv, plus your, how you said the initial velocity? But what is the height in that velocity? Well, the height would have been 0. In initial velocity, the ball is still on the ground, so it's 0. So we don't need to worry, plus 0. So just this. So what is our initial velocity? In this case, it's just 7 root 6. Our final velocity we want to reach. Now, you should also know, we know that when a ball goes to the maximum height, its actual velocity goes to 0. You should know that. So when a ball goes for projectile motion, it reaches a point where its velocity actually is 0, and that's where the maximum height occurs. So we want to go from this velocity to 0 of this whole equation. So let's write that in our calculator. So 7 root 6 is 0 negative v. Oh, no. Okay, make sure. Let me just copy that, because I don't want to ruin. I've already defined v, so let me just brand new that. Okay, yep. So negative v 9.8 plus 0.1 v squared dv. And enter. And we get 10 log e2. Let's write that down. So we get 10 log e of 2, which does not look like any of these answers. It is, because it's 5 times 2 log e of 2, which is 5 log e of 4. So A is your answer. Done. Nice and easy. Great. Question 18. Consider a random variable x with a property density function this. If a large number of samples, each size 100, is taken from this distribution, then the distribution of the sample mean will be approximately normal with mean this and a standard deviation equal to what? So, what are we going to do is first, we know when you have a probability density function, to find the actual standard deviation, so the standard deviation, for first, the variance of just x, in this case, it's just x in here, is what? It's the, if I'm not mistaken, it's the expected value x squared minus the expected value of x all squared. And it's because we want to find the variance, the standard deviation would be just, square root of this. So both, okay. And that's going to be your SD of x. So, okay, let's do that. So, we know to find the expected value of x squared, it's going to be the integral of, in this case, it's just 2x times x squared dx, and we're going from 0 to 1. And that is going to give us our expected value x squared. And our expected value of x is just going to be the integral from 0 to 1, 2x times x, 1x, just dx. Let's do that all in our calculator. So, expected value, so 0 to 1, 2x to the power of 3 dx. And we get half, so that's your x squared. And what about this one over here, which is just e times x squared. And that's 2 over 3. So, squaring this, remember we need to square this over here. And we're going to minus it from ex squared. So this minus this over here. And we get this. And then we square root it. Hence, we get root 2 over 6. So let's write that down. Hence, your standard deviation of x is root 2 over 6. Be careful. This is for the, the standard deviation of the normal x, but we want the sample mean standard deviation. Remember, the sample mean standard deviation is just your original standard deviation, which is root 2 over 6, divided by the square root of this how many value of S, so the sample size, which is 100, which is just 10. So it's overall root 2 over 6 divided by 10, which is just 1 over 10. So it's written as 60. Root 2 over 60 is your answer. Done. Nice. Question 19. Bags of peanuts are packed by a machine. The masses of the bags are normally distributed with a standard deviation of 3 grams. Okay, so that's good. The minimum size of a sample required to ensure that the manufacturer can be 98% confident that the sample's mean is within 1 gram of the population mean is what? Okay, so we're saying, in this case, if I draw a normal distribution and say this here is your sample mean, and we want this to be 98% here, and we want this to be like 1 gram from the population mean. So we know that Z, the width of a confidence interval, so the width is going to be S over root n. So the smallest one will equal to 1, because 1 gram. The population, we want it to be confident that the sample mean is within 1 gram, so 1. But what's our Z for 9.98%? Normally 99 we know, we also know 95% confidence, we know 68%, but what's 98? Well, you can determine by, okay, let's think how to determine Z value for that. Well, if I was drawing a normal distribution curve, we know that, let's say, we know that the mean is 0 for Z, like, this is a Z distribution, so 0, and we know that if we wanted to have 98%, what's happening to me? The minimum size of a sample required to ensure that manufacturer can be confident that is what? Bags of peanuts are packed by a machine. The masses of the bags are normally distributed over a standard deviation of 3 grams, okay? So S is 3. The minimum size of the sample size required to ensure that the manufacturer can be 98% confident that the sample mean is within that 1 gram of population. Okay. Okay, yes. So we need to, if we know this is 98% here, yeah? Then this must be like, 1% here, and this must be also 1%. So it will be, this part over here will be 0.01. So what we can do is we can calculate that Z value here. And that's going to give us our Z here. So, yeah. Yes, absolutely makes, okay, I got it, yes. That makes sense. So, go on your calculator and go on menu and go to probability and go to distributions and go to inverse normal. And, well, the area is 0.01. And we want it to, the standard normal distribution. So press it. Okay, and we get this. So it's negative 2.32, blah, blah, blah. So remember that this has to be the same. So this Z is the same as this Z. But here it's positive. Whereas here it's negative. And of course we got negative. But we want the positive. So just imagine like finding, it's the positive number of this. So it'll be 2.326348 times your S, which is 3, root n should all equal to 1, and we calculate the value of n. All right, so let's take this and times it by 3 root n, and that should equal to 1, and we solve answer, comma n. Hence, n is equal to 49. So 48.7, remember it's number of people and it has to be an integer, so it's 49. So D is your answer for that one. Yeah, that was actually quite, I don't know what happened to me. I froze to find the 98% Z value. Yeah. Question 20, so last question. Nitrogen oxide emissions for a certain type of car are known to be normally distributed with a mean of this and a standard deviation of this. Okay, for two randomly selected cars, the probability that their nitrogen oxide emissions differ by more than 0.5 kilo, this is closest to what? So we want the probability that their nitrogen oxide emission differ by more. So, okay, so let's say this is car 1 minus car 2 must be more than 0.5. This is what we're trying to find. But be careful. This is the case that we're making that, car 1 is actually great. Car 1, the difference is car 1 is, greater than, this. So, like, yeah. It could also be that the probability that, C2 minus C1 is greater than 0.5. In this case, they're not telling us which car it is. They're just saying two randomly cars. So we have two cases. So be careful. So the overall probability that the nitrogen oxide emissions differ by more than this has to be both of these. We need to find both of these, probabilities and add them together. A lot of students might forget that. Yeah, remember the question is very, very tricky in this one because they've given you that they've just said that the nitrogen oxide emissions differ by more than this. They're not telling you which car. So it could be, we need to take the case that first car 1 minus car 2 is going to be greater, or car 2 minus C1 is this. Normally in exams, let's say, you look at, they write it like this. They could write it as probability of, say, absolute value car 1 minus car 2, which is the same as what it's the same as this, by the way, if you're wondering, pretty much, because the absolute value just replaced by plus or negative. So you can just replace them plus or negative. And it's the same thing as we did. So if you take the positive, it'll just be like, car 1 minus car 2. And if you take the negative, it's probably that car 2 minus car 1. So it's the same thing when you see those absolute value. But yeah, don't worry. But yeah, make sure be careful. The question is very, very tricky in a way because they haven't told you which car. So you need to take both cases. All right, so what do we do then? Okay, so we need to find the expected value of car 1 minus, well, find this one first. Car 1 minus car 2, which is just the expected value of car 1 minus the expected value of car 2, which is what? Which is 0 because we know that the mean is 0. Imagine like 0.875 minus 0. It's just 0. Done. And then what about your variance of C1 minus C2? It's just going to be the variance of C1 plus, remember that negative one gets squared, so plus variance of C2. So, in other words, we're saying 0.188 squared, 88 squared. And then, to find the SD, the standard deviation of C1 minus C2, it's just going to be the square root 0.188 squared, 188 squared. So let's do that. Square root 0.188 squared plus this. And it gives us this number, 0.2658721. So I'm going to rub everything out and just keep that one. I'm going to rub everything that we don't need. So we don't need these calculations anymore. And pretty much we only don't need this. And now we know that the expected value is just 0. So we can write 0 here. Done. We've got everything now. And so that's for this one. And we can just, calculate the probability for that. Then we also have to do this. But be careful. No, not even be careful. It's just like, isn't it the same value as these? Like the expected value of C2. So C2 minus C1. It's, the expected value of C2 minus the expected value, which is still 0, because remember, it's the standard deviations are the same. So again, we get 0, and the standard deviation of C2 minus C1 is also going to be the same, because the standard deviations are for both cars the same. So it's like repeating everything. So in other words, they're kind of the same. So yeah. So what we're going to do is, overall, if this probability means that this probability is equal to this probability, so we can rewrite this whole expression as, like, cancel this out, and we can write it as 2 times. Like, it's 2 times this over here. So let's use our calculator. So let's first calculate the probability of this and then multiply by 2. So if we go menu and go to probability, well, let me copy this actually. All right, so probability distributions, this. And so we know that the lower bound is going to be 0.5 and it's going to go to infinity. We know that the mean is 0 and the standard deviation is this. Press OK, nothing. Let's try it again. That's that. That's 0.5 and that's infinity. Enter, and we get this, remember, and then we're going to multiply by 2 because remember what we just did. So we have to multiply by 2 and that gives us 0.06, which is B as your answer. Done. I hope you kind of understood what I meant by this. I know the last question is very tricky in a way a lot of students make that mistake, but yeah, so you need to think about the two cases that you just can't say that, you know, C1 is minus C2. It has to be, it could be C2 minus C1. So you have to take both cases, and that's why it's just, yeah, twice the probability. Yeah, guys, I hope you guys learned, you know, something through this video. Please make sure to like and subscribe and share this video with your friends. Thank you guys for watching and take care of yourselves.